Welcome to GateX AI/ML. In this video, we'll see few more concepts on optimization. So first we'll understand the concavity or convexity of a curve, how to find it. Okay. What is concavity or convexity? So suppose say if I have a curve like this, okay, this we call it as concave up or convex. Okay. Suppose if I have a curve like this, okay, then I say it as concave, okay, only concave or concave down. So this is called convex up, or you can find, yes, the curve is like this, it is concave or concave down. What are the conditions? Okay, so we can do it easily using your second derivative test. So you have use this to find your local maxima or minima, same thing. So if the second differentiation at point C is a critical point here, then f of C is local minimum, that is concave up. That means what? At this point, that's what this, if it is your local minimum, okay, so for this curve this is the local minimum, then I will have a horizontal tangent like this. So here your f dash of C will be equal to 0. So what exactly it means? The second differentiation gives you whether the curve is increasing or decreasing. Draw tangent at this point somewhere here, this indicates the curve is increasing on both sides. That means this is the lowest point, that is the local minima. If curve is increasing like this, if you see here, it is concave up, so it is forming like this. Similarly, if f double dash C is less than 0, then it will have a point here, a maxima tangent like this, where f dash of C equal to 0, then the curve is decreasing from that point both sides, so that we call it as concave or concave down. Let us see an example. So given f of x equal to x square, if I calculate f dash of x to find the critical point equal to 0, then I will get my critical point c or x equal to 0. So if you observe this is the curve for x square. So this is our local minimum, okay, or relative minimum. So that means what? F double dash of x, so f double dash of x will be equal to 2. 2 is greater than 0. Therefore, the curve is concave up, or also called as convex. Okay, this is how the curve looks. So without seeing the graph, you can use the second derivative test and then find whether the curve is concave up or concave down. Okay. So that means what? F double dash of x greater than 0 means slope f dash of x. Okay, this is slope here parallel to your x-axis or horizontal line is increasing. The graph bends upwards, so the graph is bending upwards. So that is the meaning. So hence it is concave up. Similarly, to take f of x is equal to minus x square, and again your critical point will be f dash equal to minus 2x. That implies x equal to 0. So there's a critical point here at x equal to 0. Now test for concavity. So you have double dash of x, if you take, it becomes equal to minus 2. This is less than 0, hence the curve is what? Bending downwards. So here is my tangent, slope of the tangent. Then it is decreasing from this point. So the curve is bending downward. This is called curve is concave or concave down. That is how you have to test. Now, if f double dash of c is equal to 0, you already know is inconclusive. You cannot say anything about this because it creates a saddle point or point of inflection here. So here at this point, curve is neither increasing nor decreasing. So for example, f dash of cube is equal to 3x square. So critical point x equal to 0. Now if you observe, f double dash of x is equal to 6x. So at x equal to 0, it becomes 0. So f double dash of 0 equal to 0. So I cannot say whether the curve is increasing or decreasing. So f double dash of c equal to 0 means slope f dash of x. Slope f dash of x is not strictly increasing or decreasing. Concavity changes sign. So point is an inflection point. So that is the meaning. Next, we'll come to some of the few theorems which are very helpful in solving many real world problems, engineering problems. Okay, the first one is Rolle's theorem. What it says, the concept is very simple. Let f of x be continuous on closed interval a comma b and differentiable on open interval a comma b with f of a equal to f of b. This is the condition. What they are saying, the curve is like this. Let's say these 2 points. This, okay. So this is my a on x-axis. This is my b. Okay. This curve is continuous in open interval. Sorry, in closed interval and differentiable on open interval. So let's say this is my f of a, means value at a, function value at a, and this is f of b, and both are equal at this point. Then a horizontal tangent line inside the interval, that is, draw this, connect this, that's a horizontal tangent line, or you also call it a secant line. The function starts and ends at the same value, so it must reach a maximum or minimum in between. So if you take this curve, okay, so I just draw a secant line or a chord. So this is, there will be a point here, they are saying this point, whatever this point, let's mark it as C, will be either a maximum or a minimum. If you observe this curve, this is definitely a minimum for this function in this given interval a comma b. Okay, at a maximum or minimum inside a comma b. So open interval, that means excluding these end points. Okay, the slope of the tangent is 0. So the slope of the tangent at least one point is 0. This. So this is 0 horizontal. So it helps us to identify where the function slope changes the direction. So those are the critical points. Mean value, sorry, the Rolle's theorem. So let us take an example. Let f of x equal to x square minus 4x plus 3 in a closed interval 1 comma 3. So what about f of 1? F of 1 will be equal to 0. Okay. So put 1 in this. So 1 minus 4 plus 3 is 0. Then f of 3. F of 3 is equal to 0. Okay, if I put 3 here, 9 minus 12 plus 3 is 0. So these are the points. This is f of a 1. This is f of 3. So this point is a equal to 1. This is b equal to 3. So what it says, the derivative f dash of x. So there will be tangent is horizontal. That's what they're saying. F dash of x equal to, if I differentiate this curve, is 2x minus 4. So the critical point C will be equal to 2. So at x equal to 2, the tangent is horizontal. This is x equal to 2. So if you observe here, if I draw f dash of C, here this is horizontal, joining these two. So this guarantees that there is some point which is minimum. So if I take f of C, it will be the minimum of this curve. So let us say f of C is equal to, C is 2. So 4 minus 16 plus 3. Okay. So this will be, sorry, 4 minus 8 plus 3. So minus 4 plus 3 is minus 1. So this is, value is minus 1 here. So this is the minimum of this, local minimum of this curve at this point. That is what the Rolle's theorem says or guarantees. So Rolle theorem guarantees this is the condition f of a equal to f of b, then there exists at least one critical point where we'll have a local maxima or local minima. If the curve was something like this, then I would have got a local maxima between these 2 points. That is the meaning. Next is the mean value theorem. One of the important theorem to solve many problems. What it says, let f of x be continuous on closed interval a comma b and differentiable on open interval a comma b. So then there exists at least one point c that belongs to open interval a comma b such that f dash of c, the slope, okay, the slope of the tangent is equal to f of b minus f of a divided by b minus a. What exactly it means is the tangent slope is equal to secant slope, okay, from those points a to b. What exactly it means is, so if I draw a curve like this, so if I take any 2 points, a, this is at a, this is at a, and this is at b. Secant line joining these two. Oops, the secant line, we call it as a secant line or a chord. A chord or secant line joining these 2 points actually indicates your average rate of change, not instantaneous. See, when you differentiate f dash of x is instantaneous rate of change. So when I draw a chord or a secant line between 2 points in the curve, it actually indicates the average rate. Then what this theorem says, there exists some point C, okay, some point C. If I draw tangent at that point, the tangent will be parallel to this average rate, and then we'll have this is actually some minima or a maxima. That is the condition. See, it need not be maxima or minima. It says some point of time this average rate is equal to my instantaneous rate. See, dash of x is instantaneous rate of change. That already you know. Instantaneous rate of change. So if I get the secant line or a chord, secant line indicates the average rate of change. Okay, when f dash of c equal to f of b minus f of a divided by b minus a, then it says that at that point c, the average rate of change is equal to instantaneous rate of change. Okay, let us take an example. So where it is important, how it is used is proves existence of points with specific slopes, important in error estimates, inequalities, and function analysis. So these are the uses of MVT. Let us take this example. Let us take f of x equal to x square on the closed interval 1 comma 3. This is my 1, this is my 3. So this is f of 3, this is f of 1. Now, what is secant slope? This green color line you observe here, right? Green. This is a secant line that is joining between the points A and B on the curve. Now, so what it says, if I take f of 3 minus f of 1 divided by b minus a, that is 3 minus 1. This will be equal to 9 minus 1 by 2 equal to 4. Now, what is this 4 indicates? So if we take the derivative, so f dash of x is equal to 2x, okay, and then set this f dash of x equal to 4, because this theorem says, okay, and then we'll get that point c is equal to, that is 2x equal to 4, that implies x equal to 2. So at this point, okay, x equal to 2, that means this point here. So this will be f of c. So at this point, the average rate of change, okay, at x equal to 2, the average rate of change is the green line, no? Average rate of change. So, and then this is the slope to the tangent at this point. So these two are, see, if you observe, they are parallel. So at this point, this become, the tangent becomes, this is the red color is the tangent. This tangent becomes parallel to, or parallel to my secant line. And this is the point where the instantaneous rate of change. This red line indicates instantaneous rate of change. Then the green line indicates our average rate of change. They are equal at this point. See, for example, at this point, they are not equal. the same curve, same values. If I take a slope at this point, it looks something like this. It is not parallel to this line. So this is the mean value theorem. Okay. So next we'll solve many more problems, then you'll understand. Thank you for watching. Please like, subscribe and share. We'll continue in the next video.